So step 1 is what we did back in 7.1. It's to find our axis of symmetry in vertex. We use the same formula every time. This x equals negative b over 2a. That's what you're always going to start with. And then once you figure that out, you plug that in for x to find your corresponding y. We are going to go ahead and flip this sheet of paper over, and we are going to do that step on our first example. So I'm going to flip this over. I put all of the steps on the front, and then I put the 2 examples on the back. So our first example we've got is 4x squared minus 16x plus 7. We are going to label A, B, and C over on those lines to the right. Our A value is 4. Our B value is negative 16. And our C value is 7. So 4, negative 16, and 7. Our formula to find our x is always negative b over 2a. It always has been, it always will be. So x equals negative b over 2a. And then we are going to plug in our b value, and we are going to plug in our a value. What is our b value here? We literally just wrote it down. What's our b value? Negative 16. Our formula is negative b, though. So negative 16, we make it a positive. You got it. So this is going to be positive 16 on top over 2a, which is going to be 2 times 4. What's up? I still didn't hear you. Do you have a question? Okay. So then we're going to multiply out the bottom there. 2 times 4 is 8. So now we have 16 over 8. And then 16 divided by 8 is 2. Okay. That is our x, which is the x value of our vertex. So we can also write that down here, that is 2. We can also graph that as a dotted vertical line at 2. So on my graph, I'm going to graph a dotted vertical line, and this vertical line is going to chop my graph perfectly in half. Your graphs today, you need to be super delicate with, because we're going to be graphing really minute details. You guys will see in a second when we do our zeros. Okay, any questions about that? All right, now we are going to plug in 2 for x. So we are going to now take this x equals 2. We're going to plug it in here and here in parentheses. So we're going to do 4 times 2 squared minus 16 times 2 plus 7. I know I'm writing over the graph a little bit. I can work that out by hand. If I work it out by hand, especially today, now that 4 times 2 squared. What? Now that we've got 4 times 2 squared, I'm going to have to know that I need to do order of operations and do the 2 squared first. If you want to put it in a calculator, you can do that as well. So it'd be 4, open parentheses, 2 squared minus 16 times 2 plus 7. And that will give me negative 9. So if I want to do it in a calculator, I can do it in a calculator. If I wanted to do it by hand, I would need to do 2 squared first, which is 4. And then 4 times 4 is 16. And I've got negative 16 times 2 is negative 32 plus 7. And then if I added that all together, I would get negative 9 as well. Okay, do you guys have a question over there? Stop talking. JP, you can get off your phone. Pay attention. What? Get off your phone. Okay, so We are now going to graph the point 2, negative 9. So we're going to go over 2, down 9. Put a dot there. Okay. Before we flip back over, talk about how to find our zeros and then find our zeros, does anyone have any questions about finding our axis of symmetry?
What I got behind. So I messed up.
Okay, we can fix your mistake later.
So 2 negative 9?
2 negative 9, yep, okay. Okay, so we're going to talk about finding our zeros now. To find our zeros, we are going to factor by grouping using our 7.4 lesson. So this is what's different about today and what we did on Monday. We have to use our 7.4 lesson to factor. How we do that is we find those two numbers that multiply to AC and add to B. We use this magic X. Once we do that, we split up our middle term and we factor by grouping. So we've got the X here, we've got our steps here, and we've got this table up here that tells us whether we're going to use positives or negatives. Any questions? Okay, so pay attention and ask questions as we go. All right, flip this back over. We are going to factor. I'm going to rewrite my problem right here. I'm going to write small. If on your assignment you need to do work on a separate sheet of paper, you are more than welcome to do that and turn that in with your assignment. We've got 4x squared minus 16x plus 7. That is just me rewriting the problem. I'm then going to draw my x over here so I can figure out what numbers to use to split up my middle term. I need to find two numbers that multiply together to be a times c. My a times c here is 4 times 7. That's 28. So my two numbers need to multiply to 28. And they need to add to my b value, which is negative 16. So multiply to 28, add to negative 16. Okay. Any questions about that x before we fill it out? Okay, so then we can list out our factors of 28 if we need to. I'm going to do so over here. My factors of 28 are 1 and 28, 2 and 14, 3 doesn't work, and then 4 and 7. First hour. In order to multiply to be positive but still add to be negative, I could use my table on the front, but I'm not going to take the time to flip back and forth because I know some of you guys are looking at this. So the table on the front would tell me I need to make everything negative. Then I pick which ones of these add together to be negative 16, which is negative 2 and negative 14. Because negative 2 minus 14 is negative 16. I now use those two numbers to split up my minus 16x. So I now have 4x squared minus 2x minus 14x plus 7. And that is what I'm going to factor by grouping. Okay. Any questions right now? All right. So I can go ahead and factor this by grouping. Out of 4x squared and negative 2x, I can divide by 2 and I can pull out an x. So I'm going to pull out a 2x here. That will leave behind 4x squared divided by 2x will be 2x. And then negative 2x divided by 2x will leave behind minus 1. Out of negative 14x and plus 7, I can divide both of those by 7. And since the 14 is negative, JP, do you have a question? Pull out a negative 7. So I'm going to divide by negative 7 here. Negative 14x divided by negative 7 is 2x. And then positive 7 divided by negative 7 is negative 1. Okay. 2x minus 1 and 2x minus 1 match, which is what I want. And then my factored answers are 2x minus 1. And then my other one is this 2x and this 7. So it's going to be 2x minus 7. Okay. Questions right now before we solve those, set those equal to 0 and solve. Okay. I'm going to set them equal to 0 and solve underneath the graph right there. So I'm going to set 2x minus 1 equal to 0. To solve that, I would first add 1 to both sides. So then I would have 2x equals 1. And then to solve that, I would then divide both sides by 2. And that would give me x equals 1/2. If you guys remember back in 7.4 when we got fractions, that's going to happen again today. So my x is 1/2 is my first one. My other 0, I'm going to set 2x minus 7 equal to 0. For this one, I would add 7 to both sides, so I would get 2x equals 7. And I would divide by 2 here as well. So I would get x equals 7/2. I'll show you how to graph it, okay? Okay, so is it confusing to graph or confusing? What do you have a question right now?
Like, where for example, 1/2 is going to be.
Yeah, okay, so where it's going to be on the graph?
Yeah.
Okay, so we want you to write your zeros as fractions here. If you would like to convert them to decimals using a calculator or just by converting them to decimals, to graph them, you are more than welcome to. So if I were to put 1/2 in a calculator, 1 divided by 2, that is going to give me 0.5. So that means I'm going to put a dot on my x-axis as a 0 between 0 and 1. Are your graphs today going to be perfect? No, because you can't find exactly halfway between 0 and 1, but it needs to be between 0 and 1. Then, if I were to put 7/2 in a calculator, what is 7/2 as a decimal?
3.5.
3.5. Yep, if you do 7.2, it's going to be 3.5. So then once we have that, we can just know it goes between 3 and 4. So between 3 and 4 on your graph is where it'll go. And remember, you're going to have fractions today, because if you didn't have fractions, it would be factored the way we factored on Monday. Okay, questions right now. We are almost done. There's one last step, and it's the easy step. Brandon, Josh, stop talking. Unless you have a question about what we're doing. Okay, so last step is to find our y-intercept. Our y-intercept is always going to be our c value, just like it was in 7.5 on Monday. So, reason why our y-intercept is our c value is because if I were to plug in 0, I would do 4 times 0 squared, which is 0, minus 16 times 0, which is 0, plus 7. So my y-intercept is always going to be just 7.
And I knew that you were going to say that because I already know that.
Yep, so we know that from 7.5. Okay, so then I can go on my graph and I can put my y-intercept at 0, 7, and then I reflect it the same way I reflected it in 7.5. So it's 2 to the left, and now I'm going to go reflect 2 to the right. Okay, that is it. You guys are going to have a lot of tall, skinny graphs today. You're going to have to connect them really carefully into a tall, skinny U shape. Put some arrows on the end, and then you'll be good.
That looks like a unicorn horn. Like an upside down unicorn horn.
Focus. Okay, any questions before we move on to our next example? Okay, so we've got one more example. We are going to go through this one. We're going to do all the same stuff, graph it as we go. So we've got 9x squared plus 18x plus 5. What is my A value? What is my B value? And what is my C value? Okay, I'm going to go ahead and I'm going to do this a little bit backwards. I'm going to put down that my y-intercept is 5. I can't graph it yet, though, because I don't have my axis of symmetry, but I'm going to go ahead and put that down there. All right, my formula to find my x is always the same formula. What is that formula? What does x equal? Over 2a. Yep, negative b over 2a. Okay, I'm going to plug in my b value. My b value here is 18. So negative 18 will go on top. Over 2a will be 2 times 9. Mm-hmm. 2 times 9 on bottom is 18. So now I have negative 18 over 18. And that will divide out to be?
Negative 1.
There we go, negative 1. So our vertex is going to be negative 1. Or our axis of symmetry is going to be negative 1. That's the x of our vertex. So I'm going to go ahead and draw that on my graph. Okay, then I'm going to plug in negative 1 for x. So everywhere there's an x, I put a negative 1 in parentheses. So I'm going to have 9 times negative 1 squared plus 18 times negative 1 plus 5. And then I'm just going to throw that in my calculator because especially with the negatives in the order of operations, I'm going to outsource this work to my calculator and let my calculator do the work for me. So 9 times, I forgot a negative. 9 times negative 1 squared. 9 times negative 1 squared plus 18 times negative 1 plus 5. And I am going to get negative 4. So that is going to be my y value of my vertex. Any questions about that? Okay, we can go ahead and graph it. So it's going to go right there at negative 4. Okay. For factoring, I'm going to rewrite my problem because I like to have it right here so I know what I'm going to split up. 9x squared plus 18x plus 5. I need to find two numbers that multiply together to be AC. My A times C here is 9 times 5, which is 45. And then they need to add to be 18. So when I see the number 45, the first thing I think about is 45 minutes. How can we split up 45 minutes? 3 15-minute chunks. And so I right away see those numbers, and I'm like, those are the ones I need. And so I'm not going to list out the rest of mine. So 3 and 15 multiply together to be 45, but they add together to be 18. So I know that those are the numbers I need. So I've got 9x squared still. And then I now have plus 3x plus 15x plus 5. From 9x squared and 3x, what can I divide 9 and 3 both by? 3, and then I can also pull out an x. You're ahead of me. 9x squared divided by 3x will give me 3x. And then 3x divided by 3x is going to give me a 1. So I got 3x plus 1. I had a lot of people on 7.4 who either left plus 0 there or plus x. Anything divided by itself is 1, not 0, not x. From 15x plus 5, I can divide those both by 5. Good job, Chelsea. 15x divided by 5 is 3x. And then 5 divided by 5 is 1. So then my fully factored answer will be 3x plus 1, because those are my matchy-match guys, 3x plus 1. And then my other guys will be the 3x and the plus 5. We are going to set them equal to 0 and solve. If you can see the pattern of how you solve them and what fraction you end up getting, it's the opposite of the sign, and then it's going to be the last number over this number, the last number over this number. If you can see that pattern and skip over setting them equal to 0 and solve on your assignment, that's completely fine. We're going to do it in notes just for good measure. So we're going to take 3x plus 1, set that equal to 0. We would have to subtract 1 from both sides, which for the sake of space I'm not showing. We would then have 3x equals negative 1. Then we would divide both sides by 3. So we're going to have x equals negative 1/3. That's one of my zeros. And if you guys can see, this turned to negative 1/3. This one's going to turn to negative 5/3. I'll show you guys how that one would work. We'll have 3x plus 5 equals 0. We would subtract 5 from both sides. We'll get 3x equals negative 5. And then we would divide both sides by 3. And we'll get x equals negative 5/3. Okay, we need to graph those zeros and we need to graph our y-intercept still. Before we find those zeros as decimals and graph them, does anyone have any questions? Okay, so in that case, negative 1/3 as a decimal, negative 1 divided by 3, is negative 0.33333. So that means it's going to be negative, and it's going to be in between 0 and negative 1, but closer to 0. So I'm going to put it right there. I put it like touching 0, because it's closer to 0, but it's on the left side. Then negative 5/3 is negative 1.6666667. So that's going to be in between negative 1 and negative 2, but a little bit closer to negative 2. So again, your graphs are going to be a little wonky today. A lot of tall and skinny graphs, but just do your best. As long as it's between the right two numbers, you'll be fine. Once you've got those points graphed, we can also graph our y-intercept, which is at 0, 5. And then since that's 1 to the right of my axis of symmetry, I'm going to draw point 1 to the left. And this one is like the ultimate super tall, super skinny graph. We can connect those points, and we're done. Okay. Questions right now? Yes. Yes. Okay, I'm going to go ahead and stop the recording.